Hi guys, greetings from Bulgaria. I am Anton, and in today's tutorial we're going to talk about code coverage in Java. Here are some of the topics that we're going to cover in this tutorial. First, there will be a little bit of theory about what is code coverage, why you need to care, what are the advantages. Of course, there will be a lot of code demos and examples. So I'm going to show you how to configure properly the JaCoCo plugin, or the so-called Java code coverage Maven plugin for IntelliJ and other IDEs. We're going to use it to calculate the coverage of one sample app that I wrote. Then it's really important for you to understand the different types of code coverage. So we're going to cover that as well. And at the end of the tutorial, I'm going to show you a really interesting topic about how to use your UI end-to-end system test for calculating the code coverage of the backend. This is really exciting. I prepared one demo as well, so we'll cover this as well. Don't forget to subscribe to the channel, hit the ring bell so that you get notified when a new video is published. Many new videos are published each week. Also, in the links below you will find all of the code examples, a link to the GitHub repo, and also there will be other videos linked that are related to the topic. I will mention them later on, and other detailed articles that have been published to the Lambda test blog, because you know about code coverage there may be 4 or 5 detailed articles that can really help you to grasp really comprehensive knowledge about that. So let's get started. In order to understand, this is a sample code coverage report. In a minute I'm going to show you the code, but basically I created a sample, a demo app and a project, Java project that you can download from the GitHub repo. Here I created one really simple class. It's called calculator. And this calculator, as you can guess from the name, is responsible for doing mathematical operations, like we can add two numbers, subtract them, multiply them, divide, square, and also I added a few more operations that require a little bit more of a code. For example, calculating factorial or power. Again, here we use simple Java setup, we use Maven. In a minute I'm going to discuss the the dependencies required for calculating the code coverage and the plugins required, but basically here I used JUnit to create all of the unit tests that are part of here. If you're not familiar with unit testing, you can find a really detailed video for 30 minutes that it's going to explain all the things that you need to know. And if you want to go more in depth, there are nice video suites on the Lambda Test YouTube channel about both JUnit and TestMu, popular unit testing frameworks. So here we're going to talk much more about those tests, about the calculator, how we test them, but these are really simple unit tests for this calculator app. We're testing just whether all of the operations are working properly. Here we expect that when we call this add method, it's going to add these numbers correctly, and we're testing this with negative numbers as well. I have many tests like this for all of the operations, right? So this is a simple code coverage report, but what is code coverage? In software development, ensuring the quality and the functionality of your code is really important. One way to measure this is through code coverage. Basically, this is a metric that illustrates the extent to which your application's code is exercised by your test suite. In our case, this is unit tests. Imagine that you have an application with 100 lines of code. In our case, this is the calculator app. And if your tests run through 90 of these 100 lines, this means that the code coverage is 90%. As you can see, in our case here, we have 88. this means that we covered 88 lines out of 100. So it is a simple yet powerful way to measure the effectiveness of your tests. So code coverage is central to understanding three main things. First, it helps answer the question, have we tested enough? For example, here, if I click on this report in green, I can see all of the statements, all of the lines that have been covered. But in red, I see all the ones that have not. So when we analyze a code coverage report, you can identify if additional tests are needed to cover these untested parts. And as your software evolves with new features and bug fixes, it's crucial to ensure that the testing standards remain high. And the code coverage helps in maintaining the consistency and standards of testing throughout the software development lifecycle. A higher percentage of the code coverage can lead to early bug detection, minimizing the chances of bugs making it to production. When scaling your application or adding new features, code coverage can help evaluate the code's scalability and ensure quality. And it's really important to understand some of the core advantages of the code coverage. First, it provides clear and quantifiable metric that allowing developers to assess the code's health and more effectively. It helps in pinpointing areas of the code that lack of sufficient testing. Also, it encourages writing modular, testable code and helps in identifying and remove redundant or dead code. This can be applied also to your end-to-end tests, by the way. And code coverage is not just a metric, but it's basically a tool for building robust, high-quality software. It acts as a compass guiding developers and testers towards comprehensive testing, fewer bugs, and ultimately a better software product. Now, you will probably in the industry hear that most of the time backend or front-end developers are writing unit tests, and probably you are right. We as software test automation engineers or QAs, mainly we use also unit tests, but in other form to write these API tests, end-to-end system tests, integration tests, etc. This low-level single component unit tests, usually this is responsibility of the developers. However, many often they skip this part, and you need as a positive agents of change and the main person responsible for testing to educate them about these benefits and advantages. This is why this is really important to understand it. And one way to measure whether they are doing their job the right way is to use these code coverage reports. Now, let's see what we can do to generate these reports. I used here a plugin called JaCoCo as the site here. It comes from Java Code Coverage. And how this works. First, in a minute, I'm going to show you in the project how I basically integrated this. But JaCoCo operates by instrumenting the Java code through a runtime agent attached to the Java virtual machine as it starts, and this is also known as JaCoCo agent. When a class loads, JaCoCo instruments it and track when and how its lines of code are called during testing. And as tests run, JaCoCo collects coverage data on the fly, building a picture of the code coverage. And then post-testing, this report is generated either at JVM, Java Virtual Machine termination, or on demand if agent is run in server mode. And now let's see how we can configure that. Again, you can download everything. Here in the POM XML, as you know, we have dependencies, but also at the bottom, we have this build tag. Under the build, we have plugins, and we have a plugin for JaCoCo Maven. So after, first, we need to integrate it with Maven Surefire. Maven Surefire plugin is the default Maven plugin for running tests in JVM. So JaCoCo instruments the code post-execution by plugins like Surefire. and this make it essential to check for Maven short pipe plugin dependency when using JaCoCo. After this version, you can get that from their official documentation or Maven repository. We have these executions, right? And you need at least 2 in order everything to work fine. This is the bare minimum. So we need 2 goals: prepare agent and report. The prepare agent goal prepares the JaCoCo runtime agent to record the execution data. It records the number of lines executed, backtrace, etc. And then we have this report goal that creates code coverage reports from the execution data recorded by the JaCoCo runtime agent. Since we have specified the phase properly, in this case this is the test phase, report will be created after the compilation of the test phase. By default, the code coverage report is written to the directory target site JaCoCo index.html, and later on you can open it, upload it, or send it via email. We can also add specific other specific goals. For example, if I uncomment here, we can have this goal check. And what this means is that this new check goal is bound to verify the rule specified. The rule is given in the rule tag here, and you have the flexibility to specify more than one rule. The whole goal here is that basically we can use this tag to keep a check on the code coverage percentage. This element here, this tag specifies the element on which the rule has to be applied. In this case, this is the package level. Then we have these limits, and these are tags like counter, value, minimum, etc. They are used to limit the code coverage percentage. A command like Maven clean verified can be used to ensure whether this rule is followed or not. Now, I'm going to comment that again, and let's see. Now I'm going to run all of the tests just to see that all of them are passing. Again, we have here just unit tests, 2-3 tests per each action of the calculator test. And as you can see here, we have, I think, in total 14 tests. Based on them, we have generated the report that I showed you, that it's achieving almost 100%. However, let's see what will happen if I comment most of the tests here. Then I, through the command line here, previously I run this command, Maven clean test, and basically I'm running just this particular class here, because in this project we have other tests that I'm going to show you later, but I want to generate the report just for this particular class. Now we will execute only 2 tests, and as you will see, the code coverage will significantly be much lower compared to before. Let's see what will happen. We have now 7% if we open the calculator, right? So we have 7%, and if, for example, I uncomment some of the more this particular test about the factorial and the power, if you remember, they're testing much more code because we have more lines here, and basically the code coverage, this particular type of code coverage is calculating the lines that we covered with one of the tests. They were executed. So with just a couple of tests responsible for these 2 methods, you will see that we will significantly increase the code coverage. Let's see what will happen. We're going to rerun. Now the project is recompiled and the tests will be executed. Now, as you can see, we have 6 tests. The 2 about addition and 2 more about the other methods. And as you can see, we achieved almost 50%, because basically here we have much more methods, but just because there are just a few lines of code, basically these two methods and their tests were able to increase much more the code coverage. Excellent. Now, I want to discuss another topic, as I said, in order to understand it better. By the way, about the JaCoCo plugin, there is a dedicated article on the Lambda test blog that goes in much more details about all of the specifics. I recommend to check it out if you're going to use it. And now let's discuss the different types of code coverage. I created a special class here with some examples. I'm going to discuss 5 different types of code coverage. Until now, mainly we calculated statement coverage. Basically, we counted only the lines that were executed. Why this is important? Some of you that have the 𝑨𝒏𝒕𝒐𝒏 certification, for example, you know that in particular contexts and specifics like medical software or military software or other critical softwares, they need to, many often they need to be certified. And in different countries and in different unions, there are different certifications, but many often they require much more significant code coverage than just the statement coverage. And I completely agree with that, because, you know, when you go to the hospital and there is a specific software that is operating your eye, you want everything to be correct every time, right? So yeah, we have, just to show you the different types of code coverage, I created these really simple methods here. Do something, perform action, whatever, with these simple if-else conditions. So the statement coverage, this measures the percentage of the statements or the lines of the code that have been executed. And this aims to execute all statements in the code at least once. This is what you can calculate with JaCoCo. This helps in identifying sections of the code that have not been tested. As we saw, we have these red lines, we haven't covered them. And to achieve this statement coverage, you only need to execute 2 tests to cover this one and this line here. And here you can see the formula. Statement coverage is equal to number of executed statements of the lines divided by the total number of statements multiplied by 100. Then we have the second level is branch coverage. Again, to see much more details about these types of coverage, in the links below you will find 2 articles about that. So the branch coverage, as you can guess from the name, or sometimes it's called decision coverage, this ensures that each branch, both true and false, in the code is executed. This evaluates both true and false conditions of the decision points, not only like if else, but also switch case and others. And to achieve it, basically, you can see the formula here, number of branches divided by the total number of branches multiplied by 100. Now, since, what is the next level? The next level is called branch condition coverage. Let me zoom in. Code often contains complex conditional expressions like this, or much more complex, that depend on multiple smaller conditions. These are called here, this is called atomic part. This atomic part is a condition that does not include logical operators like and, or, nor, not, but may consist of symbols like greater than, less than, equal, etc. And this single condition can be made of multiple of these atomic parts. To achieve 100 branch condition coverage, we must test every atomic part with true or false, but as you can guess, we don't need all the combinations, because this might be true, this might be false, and this means that we cover them. But this doesn't mean that we are going to cover all of the branches. And this is the formula. However, the 4th level is branch condition combination coverage. And this expands the previous one, the branch condition coverage, by testing all possible combinations of these particular conditions. This needs to ensure that all possible combinations of the atomic conditions in this decision statements are tested. And this type of coverage can require a significant larger number of tests, especially for complex statements with many atomic conditions. And you know, one of the rules is that probably we won't have the time for all of the combinations. This is why the fifth level exists. This extends the branch condition coverage by testing all possible, not all possible, but this basically aims to test only those combinations of the conditions that affect the overall outcome of the decision. And this helps in reducing the number of the required tests compared to branch condition combination coverage, while still ensuring a thorough testing of the decision statements. There are a few other types, you can read them in the article, but these were the most important. These coverage types, they provide a hierarchical approach to testing, with each type offering a more thorough level of testing than the previous. They help in uncovering different potential issues in the code and thereby aiding in improving the software quality and reducing bugs. Keep in mind that most of the free plugins and that are part, especially of the IDEs, they usually calculate only the statement coverage. There are some paid tools that are much more sophisticated just for calculating the other types. Now, the last part of this tutorial, as I said, is that I want to show you how we can use our UI tests or end-to-end tests here written in WebDriver or even any other framework to calculate the backend coverage. This is really useful as a metric to find out what you covered with your UI or system tests, right? And this approach will be really dependent on the server technology that you're using. In my case here, I'm going to use the demo application. If you watch some of my other tutorials about authentication testing, passwordless testing and login with SMS or email codes or single sign-on, I created this demo website written in Node.js to show you that we have register, we have activate, we have reset password. You can download it from the links below. It's completely open source. You just need probably if you're going to use all of the different stuff to create some free accounts in configurations and add some links there. You can watch some of the previous videos about that. However, in one of the videos about mastering authentication testing, if you haven't checked this video, I suggest to do so. We covered many of the situations that you need to take care when you're writing automated tests for login, profile, registration, how you can integrate third-party services for checking the emails or the SMS, how you can register test users using API, and so on and so forth. Also, how to bypass two-factor authentication or CAPTCHA. So I basically got those tests from this repo and I cloned them. Here I can show you, this is the server code. Again, we don't need to talk about it now, but this is just Node.js in combination with Bootstrap and some HTML and JavaScript to run this demo. And I integrated one, and I instrumented the code with one library called Istanbul. What is Istanbul? Let me elaborate on that. Istanbul is a JavaScript code coverage tool that computes statements, line, function, branch coverage with module loader hooks to instrument the code on the fly. It allows for tracking which parts of the code are being executed when tests are run. And this is particularly useful for understanding which areas of your code base may need more testing. Or you can use it as a like between the queues, you can use it as some type of metric for progress. When used in the context of Selenium UI tests or Playwright or other frameworks, Istanbul can be somewhat trickier to implement because Selenium tests are usually black box tests. They don't have access to the server code. However, it is possible to measure the coverage of the server side code executed during the Selenium test by instrumenting the server-side code. And this is exactly what I did. Here I used 𝒏𝒏 here to compile the code. I installed like a dependency following the documentation of this particular code coverage tool. I integrate it into the app, and when I run it, it starts calculating the code coverage. And by the way, this is, let me show you the report. This is how the report looks like. As you can see here from the top, we have almost 40% of this server.js. Here's what you need to do in the tests. Basically, as I said, this is a simple Selenium setup with JUnit. Again, you can watch some of the JUnit series to see that. Also in the POM XML, just really quickly, I'm going to show you. I have REST assured. As you know, this is a popular library for testing APIs in Java. I have Faker for creating test users. I have Twilio for the passwordless login with SMS. We have all the dependencies for JUnit. I have, of course, Selenium and the WebDriver Manager. If you're using Selenium 4.11 or above, you don't need WebDriver Manager, since from 4.11 basically the driver management and the browser management is built into Selenium, which is really significant, huge. Kudos to all involved. So yeah, we also use MailSwap. This is a third-party service. Again, you can watch the videos about authentication, single sign-on, and passwordless. How to do that. And then in this authentication tests, basically for backward compatibility, before all of the tests, I'm running WebDriver Manager to download the Chrome driver, the executable. Then we start the browser before each test in the setup class. Then we have tests, for example, for the login. We are logging with particular users and checking that the particular user have been logged in. Also, we have login with the Remember Me checkbox. We have update of the profile. Let's run that. Right now, I think the server has been started, and basically when I started, as you can see, the test is green. Now the coverage has been recorded by Istanbul. At the end, when you basically stop the server, the report will be generated and we can open it. So basically, no matter where you run your tests, as long as your application has been integrated with Istanbul, if we're talking about Node.js, no matter whether you run your tests locally or in the cloud. For example, if you want to run them on Lambda test, the cloud, this will perfectly be integrated, and the code coverage will be calculated for the server if the server was instrumented. The only change that we need to do is that we need to use this capabilities generator to generate all of the capabilities for the Lambda test cloud. Provide the username and the access as environmental variables. You run the test, that's it. At the end, you have the report. However, it really depends on the technology stack that your app is using. In my case, we're using Node.js. This means that this is why I used Istanbul. However, if you're using Microsoft technologies, other tools are needed. If you're using, for example, Java setup, then probably you need to instrument the code with JaCoCo and other types of code coverage tools. For example, in one of the enterprise projects that I'm working on right now, we're using this approach for years in the Microsoft stack. Again, we're calculating the code coverage once per month just to get the metrics. That's completely fine. Keep in mind that most of the time when you instrument the server code, probably the application will be a little bit slower. So you need to take this into consideration, and probably it's not a good idea all the time the code to be instrumented, but once per month this is fine, just to get the metrics and see those points and get the numbers. Now, I think we covered most of it. Remember, while aiming for high code coverage, this is good, but it's crucial not to treat it as the only metric for test quality. Code coverage only tells you the percentage of your code that's run by your tests, not whether those tests are effective or if they cover all of the edge cases. Always combine it with other quality measures and good testing practices. And I want to show you one last thing. Lambda tests have some really great integrations, for example with 𝑨𝒏𝒕𝒐𝒗. Again, depending on your code base, you need to check whether this tool can be used or not. Here in their documentation, under the code coverage tools, you can inspect that and see whether this will work for you or not. I used Istanbul because for Node.js, this is the suggested approach. But if, for example, your application is built in Java, C#, even Kotlin, this tool might be excellent, and it's completely integrated into Lambda tests, as you can see here. And also, there is one more great article about code coverage Java tools. Top 16 are here. We just checked 2 of them. So, thank you for watching. If you have any questions, put them in the comments below. I really want to hear if you have any suggestions for future videos. Follow the blog, check the Lambda test community. Don't forget to get your free certification about JUnit and Selenium. And see you soon in other videos.